Welcome to our fall and winter outlook for the rest of this 2025 into the first couple of months of 2026. This is our best guess at what the general trends this fall and winter will be like, and we'll kind of step you through how we put this together and why we think the way we're thinking. First of all, if you really want to get to the meat and potatoes without watching this whole video, watch the beginning, then scroll down to the end or swipe your way down to the end. The middle of this will be kind of our methodology and how we put things together and what we're seeing and why we're thinking the way we do. First of all, these are the highlights. And what we're going to do is we're going to look October to February. When we get into March, April, and May, it's kind of a different ball game, and that's something that we can look at in maybe December or early January, but we're going to concentrate on October to February. So March, April, and May is not going to be included here. And those are very important months, but we're too far out for that stretch. First of all, these are the highlights. We're going into what's called an ENSO neutral. What does that mean? It means we don't have a La Nina, we don't have an El Nino. Now, it's been a while. The last time we've been in a neutral situation out in the Pacific was the year of 2019. And we're going to go back to 2019 because we think that's the strongest analog to what's coming this winter. Now, what tends to happen historically in neutral winters is you have high variability. You're less likely to get stuck in a rut like you do with a strong La Nina or a strong El Nino during the cold season. What this means is a lot of action. You're going to have a lot of weather, but you're going to have a lot of ups and downs. But you don't tend to be in prolonged periods for too long in neutral situations. We also have some similarities to last winter, mainly when it comes to the warmer waters in the North Pacific. The sea surface temperature anomalies are going to be playing a really big role across the North Pacific, meaning the Gulf of Alaska to northeast of Japan in that northern corridor there. Also, the subtropics right along the equator. Those are the two areas that are going to play a really big role, as well as what happens in the far eastern Pacific. There is potential for a colder fall, or at least a colder fall punctuated by, let's say, cold events. This is something we've seen in neutral falls before. You can have some really warm periods in the fall, but you could also be hit hard with cold events and snow. And we'll go back to 2019 for that. And this is a bit different than we've seen in a while. It's been a while since we've had some cold, snowy fall events. Last time that happened, 2019. So we have moderate to high confidence as well, then a colder than average weather for a large part of the US and Canada. But with the variability, you're not going to have prolonged cold waves. But when it gets cold, it's going to get cold and snowy. And in between, you'll have some warm-ups. So that's kind of the basic highlights of what we see this fall through the February time period. Methodology. What are we using to put this together? Well, we're going to look at these three seasonal climate models, with the European and the Canadian having the highest weighting. The climate forecast system is just too unstable this far out. It's giving us some hints, but the European and the Canadian is what we're going to stick with. Those sea surface temperature anomalies, as I mentioned earlier, are going to be a really big role player in terms of how the winter will play out. In my opinion, the oceans are a large percentage of a seasonal forecast and understanding those sea surface temperature anomalies. Analog patterns. This is a little bit of old school, but what this does is it means let's take a look at years past and see how the weather behaved in those years when we see something similar, especially in the ocean patterns that we see now. There's an expression that history doesn't necessarily repeat, but it rhymes. That's kind of what we're doing here with analogs, which is we may not find an exact same year that we've had in previous years, but we can find a year in the past that may rhyme with this year. That's kind of the best way to describe how we use analogs. We're also going to discuss at the end what our failure modes are. What's a failure mode? Well, if our long-range forecast goes bust, which it can do, a lot of the summer forecasts this year went bust, we're going to discuss why they may fail. Kind of, if it doesn't work out the way we expected it, what could be the reasons for that, because that's good to understand as well. So let's go back in time a little bit. I always like to rewind. Let's go look at the last 3 winters, and let's look at the sea surface temperature anomalies. I'm just going to pick the first day of the year as sea surface temperature anomalies to kind of see how things are going to go. So let's go back to 2023, January 1st. We had a full-fledged, well-established La Nina. We had a warm North Pacific, but we also had some cold waters there along the coast of Alaska and the coast of Western Canada. What happened during the coldest months of the year, December, January, and February? That's how that look ended up. And also, I do think that the winter of 2022 and 2023, a lot of the impacts had to do with that Tonga eruption that happened in January of 2022. The effects took a little bit longer, but likely had a big impact. So these are the temperature anomalies where you see yellow or orange. It was warmer than average for the December through February period. White means average compared to the 30-year averages, and the blue means below normal. So a lot of the northern plains in the west had a colder than average 2022 to 2023 December through February. 2024, look at the difference. The opposite. We had a strong El Nino in 2024. We kind of had a hodgepodge of warmth and some pockets of cold in the North Pacific. How did that winter fare? Warm. There's a really strong correlation, we'll talk about this here in a minute, between what goes on in the Pacific. That very strong El Nino resulted in a pretty warm, look at Canada, 2024 December through February. We had an La Nina in 22-23 that led to cold. So what about this past winter? Well, this past winter, we were having a burgeoning, forming La Nina that was getting going, getting started in the fall, and then it really expanded in January and February before weakening in March and April. We had a generally warm North Pacific at the start of January of last year. How did last year end up? Like this. A lot of the nation, at least a lot of the lower 48, had a colder than average December through February. It's good to bring this up because people tend to forget very quickly, what the last winter was like, let alone the last 2 or 3. So where are we going? We talked about it being neutral. This is the prediction of sea surface temperature anomalies. You can see it's clustered just north and south of that 0 line. And those gray bars represent between now and the last here, March, April, and May, basically shows the potential for neutral to be higher than a La Nina and El Nino. We're going to see some sea surface cooling, it looks like, through the beginning of fall, and then we just stay neutral. So we're very confident that we're going to stay in neutral status. So let's look at past winters in the recent past that were neutral. Again, we saw the last one happen in 2019 and 20. I'm putting an asterisk on it because that's the analog we're going to use because it's the strongest analog. But you can see we haven't had a lot of neutral winters. In fact, we've probably have had, I know we have had, more La Nina winters than El Nino winters and very few neutrals. So it's a different ballgame this winter. We are looking at a different situation than we've seen in a while. Now, if we go back using a recent time frame that of the making of this video here in the middle of August, if we look at sea surface temperature anomalies in 2019, which we've decided is the closest analog, at least in recent neutral situations, we had a weakening La Nina, not unlike what we're having now, although the sea surface temperature anomalies are flipped, as you'll see in a minute. But we also had a fairly warm Pacific in August. Now, the summer season isn't necessarily the best time of year to imprint where we're going with sea surface temperature anomalies, but I'm just kind of laying the case, so to speak. So this is where we are now. We have a warm North Pacific. We have a similar situation, although it's warmer here and colder here. We had the opposite in 2019. But with the development of a neutral situation and a weakening of La Nina continuing, and La Nina is officially gone, but these really warm water temperatures in the North Pacific are something to really key in on as we go into the early winter season and the fall as well. So we have some similarities between this year in August and August of 2019. So what happened in the fall and winter of 2019? Now we'll talk about this some more, but I'm not showing you these maps right now to say this is what's going to happen. Remember, it never repeats itself exactly, but there's going to be a rhyming likely this upcoming fall and winter season. We had a really cold October in 2019. In fact, we had early, very hard freezes. We had significant snow events, especially in the mountains of the Central Rockies during the month of October. And some of you might remember this, all you elk hunters out there. This was the October where a lot of vehicles and campers got stranded in some of the mountains. This is from the Snowy Range, where a lot of campers and vehicles like this truck ended up spending the whole winter up there. Now, I'm not saying that's going to happen again, but neutral falls will tend to do this. So I'm just raising your awareness that this fall we could have a couple of strong fall events. November was a cold month as well. Lingering effects of that colder October. December had a little bit of a warm up for a lot of the nation. And then January really wasn't that cold, but then the cold came back in February. So basically, we'll put all of these together to show you the general trends. So what this also kind of highlights is the variability that we had through those months that we may very well have this year as well. So let's put together some composites of temperature and precipitation for the analog years. So the analog year of 2019 to 20, we'll kind of show you what it was like from October to March and December to March 1st, basically going through the month of February. So if we take a look at precipitation that fell between December 1st and the March 1st from 2019 to 2020, we had above average precipitation in California. Here's your above average precipitation in the Rockies, and it was above average precipitation in the Great Lakes. Notice the Pacific Northwest was drier, the southwestern United States, and the South. So those were kind of the trends we saw just for that year, putting those months together, looking at where the anomalies were. Where you see white, basically assume that precipitation amounts were close to average. The green below average and the yellows, the blues and the purples above average. When we take a look at precipitation rates for the fall and winter, so this is December through February, this is October through February. Notice the above average precipitation here, the below average precipitation in the Pacific Northwest, and the below average precipitation in the South. So that's how October of 2019 through February of 2020 ended up as the last neutral Pacific situation along with a warmer North Pacific. As we take a look at what the forecast is for sea surface temperature anomalies from August through February, notice the weakening of the blue going to that neutral status is basically white there, meaning sea surface temperature anomalies there are basically going to be null in the subtropical Pacific. But notice the Pacific in the north is warmer than average. And that's certainly something that we've seen here during the summer season. And I do think that's affected the summer season somewhat. So this continues to support the neutral status throughout the winter season. The Canadian model, I just showed you the European. The Canadian model keeps that warm pool in the North Pacific, but it is warmer in the subtropics, at least later on. Could this mean a developing El Nino by March, April, and May? Maybe. That's something we'll have to address later as we get a little bit closer. But the two models that we're putting the most weighting to are basically saying the same thing. Now this is where the rubber hits the road when it comes to the seasonal forecast for the winter. I'm going to show you the Canadian model and the European model and see if there's any synchronicity between the two. What I'm showing you is 500 millibars or 18,000 feet. The colors represent where there's going to be low pressure or high pressure overall, averaged out over a month at a time. The red here represents where the atmosphere wants to be warmer aloft or where you're going to get a high pressure. The blues or the whites is where you're going to have the areas of lower pressure. Generally speaking, if you average 30 or 31 days out. So the Canadian wants to put a high here and a low just north and east and near the Hudson Bay area. What this would do, this is the month of December, this would cause the jet stream to act like this. As it rides over the ridge, it takes a dip into the continental United States and Canada. That's a cold signal. Let's go into January. It's basically the same thing. It wants to keep that high over the North Pacific. This makes physical sense because if those water temperatures are warmer than the 30-year average, it makes it easier for high pressure to build, at least for periods, not permanently, but for periods, in that North Pacific, which causes the jet stream to make these dips. And for the month of February, it's saying the same thing. The Canadian is a really cold solution, much colder than the other models. But the Canadian model, as listeners to this podcast know, did perform extremely well this summer for the most part. It wasn't perfect. They're never perfect. In fact, you should never take any model I show you for face value. You want to hit the trends. You want to look at the general message it's saying, not look at specifics. You'll get in trouble if you do that. The Canadian model, if you take December, January, and February and put it together, if I were to just kind of highlight where the white is, this is where it's predicting it to be the coldest. And you can see Canada, the northern tier of the United States, for that 3-month period, these are all the days averaged together. This is what the model says verbatim. Again, don't take this at face value. I'm going to adjust this. But the look of the Canadian is a cold one. And what it doesn't show you here is forays of the cold getting further south because it's putting 90 plus days together here. So you average things out. So it doesn't mean there won't be cold shots into the southern plains or even the southwestern United States, but overall it's going to be colder across the northern tier and the central United States. Precipitation-wise, the Canadian is, anywhere you see the white and the green, is showing where the precipitation will be at or above average. Again, taking it verbatim. One thing that we see in the modeling and also the analog is a dry Pacific Northwest and West Coast, at least through February. Again, we'll tackle March, April, and May later. But what we see here, if you take the Canadian, you put it together, the cold and the above average or average precipitation, that is a cold, snowy winter for a large part of the central United States, parts of the West, and the Great Lakes. So let's go back and take a look at those anomalies again. Going back to the year 2019 through the month of February 2020. And the Canadian model is showing that dryness there. It's showing the above average precipitation there as well. This is a little bit of an anomaly that happened in 2019 The Canadian model certainly isn't showing that. That doesn't mean the model is going to miss it. It might. It may not happen as well. Again, what we're looking here are trends. So let's look at the European model. The European model is further east with the high in the month of December. So basically, it wants to direct the cold more into the Great Lakes and the northeastern United States. If the European solution ends up being correct for December, that keeps the severe cold more into the eastern half of the country as compared to the Canadian, which is more west. As we go into January, the high begins to move further west. The low is more towards the Hudson Bay area. And what that does, that pulls the colder air further west. So the European wants to keep December warm, but it takes January and then February. That's when the cold really moves in. So basically, the two model solutions are similar, but the European is shifted more east in December, more west in January and February, while the Canadian wants to make it cold in December and keep it cold all the way through February. So they're similar, but not exact. We don't expect them to be exact. But the overall message is for high pressure to be in the North Pacific, whether it's right in the Gulf of Alaska or further west towards the Aleutians. Now, the European model, temperature-wise, is showing warmth. But I have to tell you this, the bias in the European model for warmth is extremely out of whack. This is one reason why summer forecasts were so bad. The European model, the seasonal model, for some reason can't see the cold. So let's just ignore a lot of what's going on here and just maybe highlight where it's more red, because these white patches indicate where the centers of cold will be. And it really doesn't make sense the way the model's doing this. They've got to fix this. They tweaked the European model here over the last couple of years, and they've basically have put biases in that makes it too warm. It just can't see the cold. So if we kind of eliminate the bias, the message is about the same or somewhat similar. Now, it's wetter for the Pacific Northwest. It has this anomaly in the Great Lakes, an anomaly of above average precipitation in the central and northern Rockies, and basically near average conditions here. So this may look a lot different from the Canadian, but there's a lot of similarities, especially the dryness that's down here in the south and including California. But it does have the Pacific Northwest wet. And a lot of that has to do with the placement of the high pressure ridge as compared to what the Canadian model wants it to do. So what I also did was, well, let's take these 5 analogs and put them all together. Just not using 2019 to 2020, but let's put them all together. I have a really great tool that will do that. So just to review, that's what December through March 1st looks like for just 2019 for temperatures and for precipitation. But let's put all those years together. So this is the temperature anomaly for all of those analog years put together. And what we see is the anomaly of warmth tends to be here, although it's got a warm bias here. But also notice the cold bias is kind of similar to what we saw in 2019. That's why you kind of have to put these all together. Again, don't take this for face value. This is what the composite of all those years are. Remember at the beginning, I talked about variability. You tend to not to get stuck in ruts in neutral situations. You have lots of ups and downs. Precipitation-wise, this is pretty interesting. The precipitation anomaly is showing some stronger signals in this part of the country right here. If we kind of add it all together, there's really nobody in that 5-year analog in the area of the country I just highlighted that was dry. So what we could take from this is that neutral situation for that area I just highlighted could be wetter than normal if we just use the analog. Some of the modeling is hinting at that. And this is really especially true kind of in this area right here. So the analog technique is somewhat helpful. Again, things rhyme, they're not going to be exact. Temperature-wise, all of that composite right here for October through March, this includes the fall, does have a bias to that cold fall in this part of the country here, just like what we saw in 2019. Now, 2019 may be kind of affecting this graphic here a little bit, but there's also other years mixed in where that anomaly that showed up very strongly in 2019 doesn't go away. So what does this mean? Well, forgive my chicken scratch. I don't have one of those fancy tools yet to draw really cool graphics that other people can do. But this is sort of my fearless forecast based on the analogs and based on what we see with the modeling. So overall, from that December through February time period, the blue shading is where I think it's going to be during that 3-month period, on the whole, colder than average. Where I have near average or NA is probably where I have the biggest, let's say I'm not as confident, okay? So basically what I'm showing you is where the trends I think show the most with the modeling in the analog. Warmer than average in the far west, the southwest, and the far south. I think the northern plains, the central United States, parts of the Great Lakes, and all of Canada, and the east slopes of the Rockies are going to be the coldest relative to the 30-year average. I think this look you're probably going to see on other long-range forecasts, seasonal forecasts. I've made it a point not to look at other seasonal forecasts, so I'm not biased by any of them. But my guess is this is going to look close to what some other people are doing, and they're seeing the same things. I'm more analog-based than I am model-based. Precipitation looks like this. That blue area highlighted, I'm pretty confident of. Why? I just showed you the analogs over 5 years. So I do think this is going to be an area where a lot of storms are going to want to transit. So if you're in the snow removal business, if you've got livestock to feed, that blue area corresponds with the blue area there, which is what you would expect. Now, again, we have this near average zone where it could be a little bit of both. This is where a lot of variability will really take place, a lot of ups and downs. And the below average precipitation in the south, the far west, one area that may end up with better precipitation is the Pacific Northwest, but boy, the signal is rather strong, at least in some of the modeling for that. So that light blue area, above average snowfall, near average, the white area, you're probably looking at near average snowfall, but the variability, the forays of this cold coming south will lead to some icy events all the way through here. I think the northern plains, the Great Lakes, the east slopes of the Rockies, down into Colorado will probably have the highest potential for a cold and snowy winter. Notice I've got things along the divide here, and that is something that we tend to see during the winter season. And we certainly saw it this summer season. What happens along the west of the divide and east of the divide can be two different things. For you folks on the western slope of Wyoming, western areas of Colorado, into the Great Basin, I would put all your eggs in the basket for March, April, and May. I do think your fortunes will change then, and again, we'll talk about that later. So, to summarize, neutral winters bring high variability, lots of fluctuations. You can have a big cold snap, then a big warm up, but another cold snap is in the offing. You don't get stuck in ruts. I do think late September, October, compared to the past 5 years, there is an early snow and early freeze threat on both sides of the Continental Divide. This could get both sides of the divide, so kind of watch out for that, especially you elk hunters. Colder than average overall, as I just showed you with the graphic, with the divide being a big thing. And we'll talk about this in the failure modes, but this could shift east or west depending on the placement of that high pressure ridge in the North Pacific. So, cold and snowy at times, Canada, Northern Plains, Central Plains, and Great Lakes, and parts of the Central and Northern Rockies. Some of these cold shots could go far south into the Southern Plains. You don't tend to see them as strongly south as you'll do during La Nina events, but that neutral situation is kind of a bit of a wild card. If you're a weather watcher, this winter could really be quite fun. What could be our failure modes? That North Pacific high pressure ridge develops more in the Western Pacific or further east in the Eastern Pacific than I showed you. Because right now it looks like Gulf of Alaska Aleutians is where it wants to be. But if it ends up more along the west coast of Canada, that directs everything more towards the northeastern United States and the East Coast and keeps the western United States warmer and drier. So that west or eastward shift could play a really big role if it happens. If it ends up further west, well, that opens the door to the Pacific Northwest and California and the Great Basin to have a colder, more stormy winter. The North Pacific could cool off. Right now it's really warm. It's predicted to stay warm. But if we see an unexpected cooling, that means the high pressure ridge will be weaker. And if that high pressure ridge is weaker, that doesn't allow the forays of very cold air that come from the higher latitudes to the lower latitudes. If we get an unexpected cooling in the subtropics and we go back to La Nina, well, all bets are off. That would throw the winter forecast into the garbage, basically. That would shred what we just dictated here. The confidence level, though, I think with this winter seasonal forecast is probably pretty good, maybe a little bit higher than average, due to the fact that we're pretty confident we won't have La Nina coming back, at least to stay for any specific period of time, and the analog signals are fairly strong as well during these neutral seasons. A black swan event. What would be a black swan event? A big eruption like Tonga. Although that Tonga eruption is something that really happens every 200 years or so. So we're not expecting that, but you never know. A black swan event could be something like that that could alter the weather patterns across the globe. You just don't know if they're going to happen or not. But if we have a failure mode, it's going to be one of those four. Thanks for your patience in getting through this. We'll see what happens. We'll update you in early December on what that March, April, and May is looking like.